Hello, here's a short introduction to the S12CForth Framework and to Forth itself. For anybody interested in this topic, I recommend the book Starting Forth by Leo Brody. There's also a free online version of this book available at the shown link. Another recommended read, of course, is the official ANSI standard document. And for podcast fans, there are also 2 episodes about Forth on the RetroBits podcast. Those give you a nice overview about this programming language. So what is Forth? It is both a programming language and an interactive development environment. The language itself is stack-based. It is extensible. You can easily add your own language elements and customize it to anything you need. It is self-contained. There's no need for any PC-side compiler or debugger. All you need is your Forth system running on your microcontroller and a terminal screen. Forth is very efficient resource-wise. It's perfect for running on low-end microcontrollers. What does Forth look like? When you turn on an S12CForth application, you start out with a little welcome message, followed by a command line prompt. Then you can type in some instructions, and you get a result. So what happened here? We've typed in a sequence of commands, and when we hit enter, S12CForth executed it from left to right. First, it found the number 7 and pushed it onto the parameter stack. Next came number 4, and it also went onto the parameter stack of the Forth system. Followed by a minus operator, which takes the last 2 entries of the stack, subtracts them, and leaves the results back on the parameter stack. Next came the number 3. Another operator, this time a multiplication. And the dot is an instruction which removes a number from the stack and puts it onto the display. Let's go through the language elements again. We have the numbers, which are called literals. These are untyped values of 16 or 32-bit size. We have operators, which are called words. These perform operations on the stack, the command line, or any other system resource. Forth comes with a standard set of words, but new words can be added by the user, and existing words can be enhanced or redefined. All language elements are separated by whitespace, and that is the complete syntax of Forth. It's very simple, but still very powerful. Let's add a new word to the language. What did we do here? The colon is a word that defines a new word. It interprets the next command line element as a name and puts the interpreter into a compile state. The parentheses handle comments on the command line. Everything that's inside these parentheses is ignored. S12CForth indicates the compile state with a plus prompt. In compile state, words are not executed, they are instead added to the definition of the new word. Carriage return sends a carriage return to the terminal. Dot quote prints a string to the terminal. The hello world string is interpreted by the dot quote word. The semicolon finalizes the word definition and leaves compile state. And now we're back into interpretation state, and we have the greater than prompt again. To execute the word, we only have to type its name, and we see the results in the terminal. Let's look at the state of the Forth compiler again. We have the interpretation state, which is highlighted in green. It's active while the command line is interpreted. Then we have the compilation state, highlighted in red. It's active while we define new words. And we also have an execution state, which was active during the execution of our new word. For each of these three states, words can have different semantics. For example, the plus word. When it is interpreted on the command line, it adds up two numbers on the parameter stack. In compilation mode, plus will just append its execution semantics to the current word definition. The execution semantics of plus are the same as the interpretation semantics. Backslash is an example of a word where interpretation and execution semantics differ. In interpretation state, it causes the interpreter to skip to the next line, which provides another way to add a comment to Forth code. The compilation semantics are the same as the interpretation semantics. And since backslash doesn't add anything to a word definition in compile state, it does not have any execution semantics. Here's a word with three different semantics, .quote. In interpretation state, .quote prints all following characters up to the next quote character onto the terminal screen. Compilation state causes .quote to add the execution semantics along with a prepending string to the word definition. In execution state, the string that was passed at compile time will be printed onto the terminal. One last example, literals. During command line interpretation, literals push their value onto the parameter stack. In compilation state, the execution semantics and their value are added to the word definition. And during execution, the value of the literal is pushed onto the parameter stack. So what kind of words does a typical Forth environment like S12CForth provide? Here's a selection of words implemented in S12CForth that fulfill common programming tasks. For example, we have words for conditional program executions like if then else, case, and so on. But we also have words for conditional compilations, which is similar to precompiler if-defs in other languages. We have loops, we have comparisons, arithmetic and logic operations, we have exception handling, catch, throw, and so on. We have formatted printing, which is like printf in C. We have memory operations, stack operations. We even have words included for debugging, like memory dumps and so on, stack dumps, and words for terminal I/O, print words, characters, and so on. Well, this is the end of my presentation, and I hope you now have a better idea what S12CForth is. For this presentation, I've used these sound samples from freesound.org, and my presentation is licensed under a Creative Commons Attribution Share Alike license. For more information, please see the creativecommons.org website. Thank you for watching. Bye.